Chemical Reactions and Reaction Stoichiometry, Part 1. Stoichiometry is really the balancing, the mathematics, the accounting of chemistry. It looks at mass relationships in chemistry, and it's based on the law of conservation of mass, as described by Antoine Lavoisier. Basically, it says that whatever mass you have going into a chemical reaction, that's going to be the same mass that you have coming out, so that we're neither creating nor destroying matter by a simple chemical process. Chemical equations, these are going to be the shorthand way of showing what's happening in a chemical reaction. So if we have a look at the formation of water, we see that we're taking 2 molecules of hydrogen and 1 molecule of oxygen and using it to make 2 molecules of water. So we see here 1, 2, 3, 4 atoms of hydrogen in 2 molecules and 1, 2 atoms of oxygen in 1 molecule. And when we take those and we combine them chemically, we get 2 molecules of water. Notice that we still have 1, 2, 3, 4 atoms of hydrogen and 1, 2 atoms of oxygen, so that we have all of the same atoms that went into the reaction coming out of the reaction. It's just that they're now combined differently. So let's have a look at another chemical equation. In this case, we're taking the compound methane and we're combusting or burning it in air. And note that when we burn things in air, we're actually using the oxygen in the air. So we're taking methane, reacting it with oxygen gas, forming carbon dioxide gas and water vapor. The reactants are what we start with. The products are what we end with. If we take a close examination of the types of atoms and the number of atoms, we'll see that we have 1, 2, 3, 4 hydrogen atoms on the left and 1, 2, 3, 4 on the right. The hydrogen atoms came in as a part of methane, but they are produced or they leave as a part of water molecules. We also have 1, 2, 3, 4 oxygens present in 2 molecules. Those oxygens end up 2 of them in the water and 2 of them in carbon dioxide. So that overall we started out with 1 carbon, 4 hydrogens, and 4 oxygens, and we end up with 1 carbon, 4 hydrogens, and 4 oxygens. So we have neither created nor destroyed any atoms. We have, however, changed who they're combined with. In other words, a chemical reaction. So this chemical equation reflects what happened in the chemical reaction. Notice also that we have some symbols next to the substances. Those symbols tell us what the state is. So a complete chemical reaction is balanced in terms of the atoms on the left and the right. It also tells you what the states are. And in this case, we see G, which represents a gas. In other reactions, you'll see L for a liquid, S for a solid, and AQ, meaning that something is dissolved in water, an aqueous solution. Note also that there are coefficients that are placed to balance. Coefficients are the numbers in front of the chemical formulae. In this case, if you don't see a number, then that number is automatically 1. And where you do see a number, it's going to be 2 or more. In the case of this reaction, the coefficients are 2 in front of the oxygen and in front of the water. And they are used to balance the equation so that the equation as written reflects that we are obeying the law of conservation of mass. So why do we use coefficients instead of changing the subscripts? Well, the subscript is actually telling you what the composition of the molecule is, what the composition of the unit is. So when we have H subscript 2O, we're saying that there are 2 hydrogens in every molecule of water. We are also saying that there's 1 oxygen in every molecule of water. If we had changed the subscript to reflect 2 oxygens, we would actually be making a whole nother compound. All right. In this case, H2O2 is hydrogen peroxide, where H2O is water. So, balancing in this way, 2 hydrogens plus oxygen, 2 hydrogen molecules plus 1 oxygen molecule gives 2 water molecules. Whereas if we said 1 hydrogen molecule plus 1 oxygen molecule gives 1 hydrogen peroxide molecule, those are 2 different substances. Water, if we drink it, awesome. We need to drink it. Hydrogen peroxide, if we drink that, that's actually toxic. So when we're balancing an equation, we change the coefficient, i.e. the number in front. We don't change the subscript. The subscript is an integral part of the chemical formula. In our next presentation, we'll be looking at types of chemical reactions. Thank you for your attention.